Hey, I'm Mike Farrington. Welcome back to the boardroom. In this video, I'm going to share a really neat table saw technique that's more commonly done on a shaper. Now, if you don't know what a shaper is, you're not alone. This is a shaper. It's essentially just a gigantic router table. For my last few projects, I've been using this setup to cut my tenons. What I have here are two identical cutting discs spaced apart by a measured stack of spacers. These can be adjusted to cut tenons from tiny all the way up to huge, and shims can be added to tune the fit. So these cutters combined with a sliding table make for a great way to cut tenons. It's almost like cheating. However, I realize most viewers probably won't have a big shaper like this in their shop, but many of you will have a table saw. Okay, over at the Mesa Saw, you can see the same principle can be applied. Two identical saw blades, a spacer, and a tenoning jig is all that's needed. Okay, before we get started, let's take a closer look at the necessary gear. Starting with the saw blades, thin kerf rip blades are probably the best bet. They require less power and are good at removing lots of material in a hurry. Next up, you need some dado shims. I like the magnetic ones best, but any will do. This will be for fine-tuning the fit. Finally, some thicker shims will be needed. This set's from Infinity. They're so-so in quality as they're not totally flat. The set I bought comes with two that are 3.2 millimeters thick, one that's 2.3 millimeters thick, and one that's 1 millimeter. The one that I made is a 1/4 inch thick, and it's great. So these will be stacked up between the blades to cut the desired tenon. Also, later in the video, I'll explore making some shims in the shop. It's cool to be able to cut a tenon in one pass, but it's even cooler to be able to quickly set up and cut a perfectly fitting tenon each and every time. With a little math, that is no problem. So, cut a mortise in your shop with your favorite method, then measure it. Write that down somewhere. I have a few ways to cut mortises in my shop, and they don't always come out to the same size even though they're both 1/4 inch. So as you can see, my hollow chisel mortiser cuts a wider mortise than the router. It's not a big deal so long as I keep that in mind with my setup. Alright, let's put all that aside for just a minute because it's time for pro tip. My tenoning jig needs a tune-up. If you have anything that runs in a miter slot, it's possible that there's too much play. Well, here's one way to fix that. With a Sharpie, I mark a spot on each end and one in the middle. Then I beat the HE double hockey sticks out of it with a hammer. This smushes some of the steel over, effectively making the bar a little wider. A set of calipers can help make sure I don't take this too far. And then, of course, a test fit. I try to hammer the bar so it's just a little too big. And then finally, a few passes with a mill file. I take a pass or two and then a test fit until I'm happy with how the bar slides. The end result should be a snug fit with no resistance when sliding. A tiny bit of play is needed. I reattach the miter bar, and this will have my tenoning jig cutting much better tenons. Okay, let's set this up and make a cut. For the first run, I'm going to use the 250 thousandths inch shim that I made, or 1/4 inch. Now I know it's not going to cut a tenon that's actually 1/4 inch because the plate of the saw blade and the teeth are offset. So this first cut's just to establish a baseline. I lower the blades down so I can cut up through my insert. I think having a little material between the blades will help give the part something to slide on. I've had parts get lightly caught on a dado insert that wasn't totally flat. Making the cut is pretty uneventful. The next step is to measure what's left. This is in no way an accurate shoulder cut. I'm just removing material so it's easier to measure. Alright, so my mortise is 260 thou. I just cut a tenon that's 220 thou, so a shim of about 40 thousandths of an inch is needed. Well, the thinnest shim from the Infinity kit just happens to be about 37 thousandths of an inch. That's close enough for YouTube woodworking. After installing it, I make another test cut. Have a look at that. My math's worked out. Showing a measurement is no fun, so let's see a test fit. Pretty darn nice, if I do say so myself. Why don't we explore this technique a little further? How tall of a tenon can be cut? Well, this is with the blades all the way up. It's pretty close to my jig, but it should still work. On my saw, this ends up being about 3 inches. Cut just fine, and the tenon measures the same as before, so there wasn't significant run out or blade wobble. I know what you're thinking, why doesn't Mike show us a near free option? Okay, well, when I was a wee lad working in a cabinet shop, one of the old timers performed this same technique and used MDF, so let's give it a try. The results are fine, but as you may have expected, even though the MDF is the same thickness as the steel shim, the tenon comes out about 10 thousandths of an inch thinner. I would assume this is due to the MDF compressing a little when I tighten the arbor. MDF is a totally fine option. I think a better option would be hardboard, which is also known as HDF, or high density fiberboard. Being that it's denser, I think it will compress less and stay more consistent thickness over time. This stuff happens to be 3/16 of an inch thick. 1/8 of an inch would have been much better, but that isn't what I had laying around for this video. Right here I'm showing how I quickly make a bunch of shims. I drill a 5/8 inch hole. I use that hole in combination with this little jig I made. This doesn't need to be NASA level accuracy. Really the key is that the hardboard is very consistent in thickness, so it will space the blades apart evenly without introducing wobble. For this reason, I do not think plywood or solid wood is as good of a choice. I sand off any frayed bits left behind. Also, playing cards make really good shims. They're all about 10 thousandths of an inch thick, and these can be made using the same process as the hardboard shims. Same as before, cuts beautifully. The only issue is the 3/16 inch thick hardboard's an odd size, and it won't easily cut a 1/4 of an inch tenon, so go with 1/8 inch. We tested max height. Let's have a look at how thick of a tenon can be cut. Here's my best guess at a stack for a 1/2 inch tenon. Of course, this measurement will vary from saw to saw, but for my older uni saw, this works great. Looks like I overshot by a little, but still, I can cut a 1/2 inch tenon with ease. Here's a quick look at how to cut shoulders. I think it's a good idea to set up a stop block or move the fence back where the cutoff won't get trapped between the fence and the blade. There's a chance for kickback there. To me, the value of this method is the ability to come back to a setup with ease. So each time I cut a mortise with my 1/4 inch hollow chisel, no problem, I have notes on exactly how to set up for that particular bit. Same goes for my 1/4 inch router bit. This is a big time saver and accuracy increaser, if that's a word. Well, I think this is a really neat way to cut tenons accurately. Hopefully you found it useful. Questions, comments, fears, or concerns, post them below. Thank you for watching. Till next time.